Hello, in this video we're going to talk about quadratic equations. We're going to use the quadratic formula and then also complete the square. So first, before we dive into using the quadratic formula here, let's just write it down. It is x equals, and there's a good little song for it, right, too. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, there's a couple good things to know about the quadratic formula as far as like common mistakes. So there's basically two things that I see are always the wrong mistake with the quadratic formula. If you mess it up, you mess it up in one of these two places. One is just to substitute something incorrectly. So it's a good idea to write down A, B, and C explicitly before you start. So you can do this in your head, that's fine, and you don't have to write it down. But if you write it down explicitly, one, it makes sure that this is in the right form, like these aren't flipped around. And remember, A is the number in front of x squared, B is the number in front of x, and then C is the constant. So that does have to be equal to 0 for this to work. And then the other thing it does is it just helps you kind of write things correctly. So then fill everything in. The negative here means to change the sign. So it's 4 plus or minus the square root of b squared. So this is negative 4, and I would not write negative 4. Typically I will here, but make sure you put parentheses around it. It's going to be squared, so it's always positive. So then minus 4, and then a, and then c. Okay, and then it's all over 2a, which is 2 times 4. And so make sure you plug the right things in. Now, the problem we have with the quadratic formula is we want to show too much work. So you want to do this in 2 steps. You want to do 16, and then you want to make this, it ends up being positive 16. But that's where you mess up negative signs. So instead of doing that, what I strongly encourage you to do is just to do this as one operation. And if you can do it in your head, that's fine, although it's probably wise to use a calculator since you have one. So negative 4 squared minus 4 times negative 1. And then hit enter. And so you get one number for underneath the radical. Because when I am helping students solve using the quadratic formula, excuse me, say they know what they're doing, but they just make a mistake, it is 90, I don't know, I'm making up a number, so we'll say 96% of the time. But it's almost all the time that it's right here. These negative signs mess you up. Occasionally this one does, although you're pretty good at that, but it's these signs that mess you up, and this number is wrong. But if you type it all in at once, then you'll avoid that mistake because your calculator will handle those sign errors for you, and you won't make them. So do not show a middle step. If you show more work than this, I would say you are setting yourself up to make a mistake somewhere. So it's weird to say as a math teacher, but show less work. Okay, so this is the answer, right? Those are solutions, but we can simplify this, and so we like to do that. There's a perfect square in 32, 16. 16 times 2 is 32. So we can write that as 4 plus or minus, we'll write it out in 2 steps. Square root of 16 times 2 over 8. And then when you take the square root of 16, you get 4 plus or minus 4 square root of 2 over 8. Okay, so then this is another place people make a mistake. It's just with simplifying. So you can only simplify the numbers outside the radical. And the shortcut is they all have to divide by the same number. So if you can divide these 3 numbers, 8, 4, and 4, by something, then they reduce out. Otherwise, you would split it into 2 fractions and reduce from there. You would make it 4 over 8 plus or minus 4 over 8, 4 squared root of 2 over 8. But let's take the shortcut because I think a lot of people will do that. This number, this number, and this number, these 3 numbers all divide by 4. So that makes it 1 plus or minus 1, which you want it right, square root of 2 over 2. And that's your answer. This can be hard to check. But if you want to check your work, you could get the decimal here, like 1 plus square root of 2 over 2, all over 2, and then plug it back in here. You could also find the decimal and then graph this, and these are because these are your x-intercepts. And so look and see if those are your x-intercepts. Okay, so try number 2 on your own. This is one where you have to cross multiply. So we're going to slide this over a little bit. And you get w squared minus 3w is equal to w squared minus 2w. And so make sure you distribute. It might be helpful to put parentheses around that. And then, oh, these cancel, don't they? W squared minus, yeah. And so here, this is not a quadratic, actually. If you subtract these from both sides, you get negative 3w is equal to negative 2w. And then we can, let's move it to the right. So let's add 2w to both sides. So that gives you negative w is equal to 0. And so here the only solution is w is equal to 0. So there, you don't need the quadratic formula, as the w squareds will just reduce to 0. They'll cancel each other out. So this one's easy to check by plugging in w, or plugging in 0 for w on top and bottom, and you get 0 is equal to 0. Okay, the discriminant. So the discriminant is this guy right here. So it is b squared minus 4ac. Let's say the discriminant is positive. What happens? What happened up here? I got a positive 32 right here. And so that gives me plus a number and then minus a number. Those numbers are always going to be distinctively different. And so if the discriminant is positive, there are 2 real solutions. They will also be real. If the discriminant is negative, what happens? We'll say this was negative 32. Then we would have an I situation. We'd have a non-real number. We would have 2 of them because I have a plus an I and a minus an I. So I have 2 non-real solutions. And I would have 0 real solutions, which might be more important to know. So this is the case where there's no x-intercepts. And if the discriminant is 0, so what happens if it's 0? Well, this is just gone. And so you can kind of picture this radical here being gone. So you would just have 4 over 8. So you just have one solution. Your plus or minus part is no more because it's 0. So this is one real solution. And this is the situation where the vertex of the graph sits on the x-axis. Okay, so what does it mean for this problem? Well, here A is equal to 16, B is equal to negative 24, and C is equal to 9. So you could solve this using the quadratic formula and say, well, figure out the number of solutions, or let's just plug it in to B squared minus 4 times A times C and see what we get. So we'll go to our calculator to do that. And once again, type it all in at once. And sure enough, we get 0. And so what does that mean? Well, that means there is one real solution. This is a double root is what it's called. If I can spell solution right, I'll be there. Okay. But that's discriminant. Okay, we're going to look at 2 problems where we have to complete the square. One will be kind of clean and one will be not clean. So to complete the square, this works on any quadratic equation. However, it's not always pretty. But if a equals 1, it's pretty nice. Okay, so what you're going to do is a always has to equal 1. So we have to make a equal 1. Okay, well, that's true, so we don't have anything to do. Next, we're going to add the constant over. So let's add 20 to both sides. And that gives me x squared minus x. Leave a little room, and then plus 20. Then you want to think about, now you're going to actually to complete the square. So you're going to do b over 2 squared. So this is the process of actually completing the square. So you got to memorize this, b over 2 squared. And so that becomes negative 1 over 2 squared, which is 1/4. Okay, so you get a fraction, so it's not great maybe for this, but that's what we have. So we have a value of 1/4 here. And so now what do we do with that 1/4? Well, this is how we're going to complete the square. So we're going to add that value to both sides. So plus 1/4 and then plus 1/4. Okay, so now, okay, well, what did that do? Well, that created a perfect square trinomial, which means this will factor down to x and then minus. So it's always the sign that's here, and then it's always the value that's here. So x minus 1/2. And really, it's the sign that's there too. Or it's the number before it's squared. And then squared is equal to, let's see, 20.25. Let's go ahead and make that, let's see, what would that be? I should be able to do that in my head, but 81 over 4. Let's make that an improper fraction, 81 over 4. Okay, so let's pause the video, make sure you know what that, how that works and where all those numbers came from. And notice the shortcut in the pattern. But one thing to know too is that, like, if you FOIL this out, you get back to here. And so that might be helpful to look at over here. So if we do x minus 1/2 times x minus 1/2, then we get x squared, and then minus 1/2 and minus 1/2 is minus 1x, and then multiply those together to get plus 1/4. So we haven't changed the value at all. We've just rewritten it. Over here, the reason we added 1/4 is because I did it on the left. And I can add whatever I want to on one side of the equation as long as I do it to the other. Okay, now I have an equation I can solve using square roots. So just solve the equation. So square root both sides. Remember, plus or minus. This one's kind of nice because it does have a perfect square. So 9 over 2. And then add 1/2. So x is equal to 1/2 plus or minus 9/2. Those are actually two numbers you could find, right? You could do x is equal to 1 plus 9 is 10 over 2 is 5, and then subtract it. I should have done the other order. But 1 minus 9 is negative 8 over 2 is negative 4. So that is completing the square. Now, this is not the best way to solve this equation because we could factor this and just, x minus 5 and x plus 4 and be done pretty quick. But that's completing the square. It'll work on any equation. So let's try number 5. Remember to get x or a is equal to 1. To do that, you have to divide by 2. And so this is one where it's going to be a little tricky in dealing with the fractions because we have 3 over 2h and then minus 2 is equal to 0. So from here, a is equal to 1. Now you got to find b over 2 squared. Or you can do like 1/2 b. Think about it that way. So it's 3 over 2 times 1/2. 1/2 b squared. So that's 3/4 squared is 9 over 16. Okay, so that's the number I need to add to both sides. So I'm going to do two things here. I didn't move my 2 over. So let's move the 2 over. And then I'm going to add 9 over 16 and add 9 over 16. So here we can just rewrite as h, and then it's plus remember, it's whatever this number is here. So before I square it, 3/4 squared, or plus 9 over the square root of 9 over 16 is also another way to see that pattern. And 2 is 32 over 16 if I had a common denominator, and then add 9, so that's 41 over 16. And you can use a calculator if you want to. Now I can square root both sides to solve. So we have h plus 3/4 is equal to plus or minus. And the square root of 41 is the square root of 41, and the square root of 16 is 4. And then subtract 3/4 plus or minus the square root of 41 over 4. And so, from a minus, and so this can be written as one fraction if you want. -3 plus or minus the square root of 41 over 4. And that is completing the square. If you get good at it, it is actually pretty quick. It's probably quicker than the quadratic formula. If you were efficient at the quadratic formula and completing the square, on a lot of problems, completing the square is quicker. So it is a good strategy to learn. It will also come into play with other things you'll do in math, like writing equations of circles and ellipses and things, and just other forms of functions. So it's valuable to learn, and reach out if you have any questions.